All right, today we're going to tackle one of the biggest mistakes in chemistry, one that costs students a ton of marks. But hey, before we dive in, if you're serious about nailing this stuff, you've got to be subscribed to Talespire Learning with those notifications on. Okay, let's get into it.
Okay, so take a look at this. You've got a student who is asked to balance H2 plus O2 goes to H2O. Pretty standard stuff, right? Well, their answer was H2 plus O2 goes to H2O2. And bam, they lost six full marks. And you can just imagine their frustration, right? They said, but I did balance it. I made sure the oxygen atoms were equal. I mean, has that ever happened to you where you're just so sure you got it right, but then you lose all the marks anyway?
Well, today, I'm going to show you exactly what went wrong there, and more importantly, how you can make sure this #1 mistake never ever happens to you again.
So here's the thing. It all comes down to a key difference that changes everything. See, there are two types of numbers in a chemical equation, and you're only allowed to change one of them.
First up, you've got the small number, right? That's called a subscript. So in H2O, that little 2 tells you what's inside a single molecule of water. It means there are 2 hydrogen atoms stuck to 1 oxygen atom. And listen, this is the really crucial part. You cannot change this number, ever.
And why not? Well, because if you change it, you're literally creating a whole new substance. Think about it. H2O, that's water. You drink it. But the student's answer, H2O2, that's hydrogen peroxide. You know, this stuff used for bleaching, a completely different chemical. And that's exactly why changing a subscript is always wrong.
So if you remember one thing, let it be this golden rule. Subscripts tell you what the molecule is, but coefficients, those are the big numbers out front, they just tell you how many molecules you have, and those are the numbers we get to play with.
Okay, so if we can't touch the subscripts, how in the world do we actually balance an equation? Well, this is where a really important rule called the law of conservation of mass comes into play. All it really says is that you can't just create or destroy atoms out of thin air in a reaction. So whatever you start with on the left, you have to end with on the right. And the way we make sure that happens, you guessed it, by changing the coefficients.
Let's put this into practice with our original equation. H2 plus O2 goes to H2O. The very first step is always to just count up your atoms. So on the left side, we've got 2 hydrogens and 2 oxygens. Simple enough. Now on the right side, we have 2 hydrogens, but whoops, only 1 oxygen. So right away we have a problem. The oxygen is unbalanced. And this right here is where students make that fatal mistake. Their brain goes, oh, I need another oxygen on the right. So they try to change H2O to H2O2. No, remember our rule, you cannot change the subscript. So instead, what do? We add a coefficient. Let's try putting a big 2 right in front of the water. Now our equation looks like this. H2 plus O2 to 2H2O. Okay, time to recount. On the right side, that 2 multiplies everything, so we now have 4 hydrogens and 2 oxygens. Perfect! Our oxygen is now balanced. But hold on a second. We fixed one problem, but created another one. See it? Now our hydrogen is unbalanced. We've only got 2 on the left, but we have 4 on the right. So what's our next move? Yep, we've got to adjust the coefficient for hydrogen on the left. So let's just pop a 2 in front of the H2 on the left side. And there we have it, our final beautifully balanced equation. 2H2 plus O2 goes to 2H2O. But let's always do a final check, just to be sure. On the left side, 4 hydrogens, 2 oxygens. And on the right side, 4 hydrogens, 2 oxygens. It's perfectly balanced, see? We adjusted how many molecules we had, but we never changed what the molecules actually were.
To make sure this really sticks, let's put the wrong way and the right way right next to each other and see the difference.
Okay, so student A wrote H2 plus O2 equals H2O2. What did they do? They changed the subscript. They basically invented a whole new reaction to make hydrogen peroxide. Meanwhile, student B wrote 2H2 plus O2 equals 2H2O. They just added coefficients, which correctly balanced the original reaction to make more water. The result? Student A completely fails the question, student B gets full marks. It's that simple. All right, enough of me talking. Now it's your turn. Let's see if you can apply this golden rule to a brand new problem.
Take a good look at this equation, N2 plus H2 to NH3.
Now I want you to just pause for a second and ask yourself a really important question first. Can I change that little 3 in NH3? Why or why not?
Go on, think about it. I'll give you 5 seconds, and then we'll walk through it together.
Okay, you ready? The answer is no. You absolutely cannot touch that 3. Why? Because it's a subscript. It defines what ammonia is. 1 nitrogen atom bonded to 3 hydrogen atoms. So the only thing you're allowed to use are the coefficients.
So let's do this step by step. We're starting with N2 plus H2 goes to NH3. First thing, let's balance those nitrogens. We've got 2 on the left, so let's put a 2 in front of the NH3 on the right. Okay, nitrogens are good, but now we have 2 times 3, so 6 hydrogens on the right. No problem. To fix that, we just put a 3 in front of the H2 on the left. Let's do a quick final check. 2 nitrogens on the left, 2 on the right. 6 hydrogens on the left, 6 on the right. We are perfectly balanced.
See? It's like a little puzzle. And once you know the golden rule, you can solve any of them. You can really tackle these equations with confidence now.
From now on, you can look at any chemical equation and just know. Coefficients, those are my tools. Subscripts, they're totally off limits. I only adjust the numbers in front of the molecules. I never change the numbers inside them. And that, my friends, is how you protect your marks.
So there you have it. Master this one simple rule and you'll protect your marks and balance every equation with total confidence. Hey, if this explainer helped clear things up for you, do me a favor and subscribe to Talespire Learning and smash that like button. And definitely let me know down in the comments what other tricky chemistry topics you want me to break down next. I'll see you in the next one.